Hi, this is Kodanda Ramaiah, Faculty of Mathematics. Today, we are going to discussing about important topic of quadratic forms and the nature of the quadratic forms. So, the quadratic form is a special case of the bilinear form in which x equals to y. In this case, we replace y with x so that we create terms with the different combinations of x. For example, f of x comma x equals to a11 x1 y1 plus a21 x2 y1 plus and so on of a. Simplify means a linear function of a set of variables given in a vector. So that is, consider the following transformation of a square matrix A, x transpose A into x, where A is a k by k matrix and x is a k by l one vector. This transformation is referred to as a quadratic transformation or quadratic form of A. So one of the example of we have to discussing that one. A is a any square matrix that is minus 3, 5, 4, minus 2. We can compute the quadratic form by using vector x equals to x1 and x2. X transpose A into x equals to x1, x2 into minus 3, 5, 4, minus 2, x1, x2. The simplification of these three matrix, we get minus 3 x1 square plus 9 x1, x2 minus x2 square. Nature, index, and signature of a quadratic form. These are the very important topics of in our quadratic form. Index of a quadratic form. The number of positive terms in the canonical is called index of the quadratic form. Signature of the quadratic form. The difference between number of positive terms and the number of negative terms in the canonical form is called signature of the quadratic form. And nature of the quadratic form. Nature of the quadratic forms are different types. That is positive definite nature, negative definite nature, positive semi-definite, negative semi-definite, and indefinite. Based on the eigenvalues, we have to decide the positive nature, definite natures. All eigenvalues are positive. So that is a positive definite nature. All eigenvalues are negative. That is a negative definite nature. If all eigenvalues are positive and at least one eigenvalue is zero, that is a positive semi-definite nature. If all eigenvalues of negative and at least one eigenvalue is zero, that is a negative definite nature. Indefinite nature, if the eigenvalues are positive as well as negative, the eigenvectors are both positive and negative, such type of nature is a indefinite nature. Rank of a matrix. The number of terms in a canonical form is called rank of a matrix. For example, find rank, index, signature, and nature of a quadratic form. This is a given quadratic form, that is x1 square plus 2x2 square minus 3x3 square. So quadratic form will convert it to matrix form. After converting matrix x1 square plus 2x2 square, the another example of that one. Just converting the matrix of this one. The another example of the quadratic form is x1 square plus 2x2 square plus 3x3 square minus 2x1 x2 plus 2x2 x3 to canonical form by orthogonal transformation. So the given quadratic equation, based on these conditions, the given quadratic equation can be written as q equals to 1 minus 1 0 minus 1 2 1 0 1 1. So that equals to the characteristic root equation of that matrix is lambda cube minus s1 lambda square plus s2 lambda minus s3 equals to 0. S1 equals to sum of the main diagonal element, that is 1 plus 2 plus 1 equals to 4. S2 equals to sum of the 2 by 2 minors of diagonal elements, minor of 1 plus minor of 2 plus minor of 1, that equals to these elements, that finally S2 equals to 3. S3 equals to determinant of the given matrix is 0. So substitute S1, S2, S3 in equation 1, that equation can be written as lambda cube minus 4 lambda square plus 3 lambda plus 0 equals to 0. That simplification of equation is lambda cube minus 4 lambda square plus 3 lambda equals to 0. Lambda for common for all terms. So lambda into lambda square minus 4 lambda plus 3 equals to 0. The simplification is lambda equals to 0. And lambda cube minus 4 lambda plus 3 simplification is 3 comma 1. Totally eigenvalues lambda equals to 0 comma 1 comma 3. So corresponding eigenvalues, so find out the eigenvectors also. To find the eigenvector corresponding lambda equals to 0. So 1 minus lambda minus 1 0 minus 1 2 minus lambda 1 0 1 1 minus lambda x1 x2 x3 equals to 0 0 0. Substitute lambda equals to 0 the above matrix, and simplification of that one is x1 minus x2 plus 0 x3 equals to 0 minus x1 plus 2x2 plus x3 equals to 0 0 x1 plus x2 plus x3 equals to 0. All three equations are non-identical. Hence, they choose any two equations to solve for x1, comma x2 and x3. So consider 1 and 2. So x1 minus x2 plus 0 x3 equals to 0 minus x1 plus 2x2 plus x3 equals to 0. Solving these two equations, we get x1 equals to 1, x2 equals to 1, x3 equals to minus 1. So this is the first eigenvector for corresponding lambda equals to 0. The second eigenvector for corresponding lambda equals to 1. So that implies 1 minus 1 minus 1 0 minus 1 2 minus 1 1 0 1 1 minus 1 x1 x2 x3 equals to 0 0 0. That implies 0 minus 1 0 minus 1 1 1 0 1 0. All three equations are non-identical. Hence, choose any two equations to solve for x1, x2 and x3. So let us take equation 1 and 2, solving these two equations.